pinacol-pinacolan rearrangement reaction. Right. So you see, in pinacol-pinacolan rearrangement reaction, generally 1, 2 diols. These are involved. 1, 2 diols means these are also called as vicinal diol. Okay, 1, 2 diols or vicinal diols are involved in pinacol-pinacolan rearrangement reaction, and this rearrangement is acid catalyzed rearrangement reaction. Okay, this rearrangement is acid catalyzed rearrangement reaction. So here in presence of acid, here catalyst reaction can be takes place. So here use in place of these mineral acids. So mineral acids means HCl or H2SO4 or HNO3, like this can be used as catalyst in this reaction, or we also used as acid chlorides. Acid chlorides are also used as catalyst in this reaction, and in place of this acid chlorides we use ZnCl2. Zinc chloride also used as catalyst in this reaction. Okay, so it is acid catalyzed rearrangement reaction, and after the reaction completed, the compound formed is carbonyl compound. Okay, here carbonyl compound means aldehydes and ketones both are present, but in most of the cases here the product is ketone. Carbonyl compound. In the carbonyl compound, in most of the cases, the product formed is ketone, and best example is pinacolan. So that's why it is called pinacol-pinacolan rearrangement reaction. Here, pinacolan, it is a ketone, and 1, 2 diols. Pinacol also taken as an example for 1, 2 diols. So here, pinacol can be converted into pinacolan by using acid catalyst. Okay, that's why it is called pinacol-pinacolan rearrangement reaction. Okay, great. Now we take that examples. So by taking this example, we can explain this reaction. So it is takes place in presence of acid catalyzed. Right. So here we take an example to explain about this. So the first example, I take like CH3, 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 CH3. Now in these two places I take OH, OH. Okay. Two OH groups are present. Two OH groups means it is diol. Okay, if you want to write the name of this compound in long chain, 1, 2, 3, 4. 4 carbons are present. That means bute. And second place, third place, methyl groups are present. So those can be taken as substituents. So we write 2, 3. 2 times methyl group is present. So we write 2, 3 dimethyl, and total 4 carbons bute. And second place, third place, OH group is present. So we take 2, 3 dimethyl bute 2, 3 diol. Okay, this 2, 3 dimethyl bute 2, 3 diol is pinacol. Okay, it can be taken as pinacol. And you see, this reaction takes place in presence of a mineral acid already we studied. So that place we take H plus. Okay, so after migrating, the compound formed is like this: CH3, 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 and now you see here you can take like this: CH3, C double bond. Okay, so ketone is formed. Here you see 1, 2, 3, 4 on third place. First carbon, second carbon, third place. In third place, 2 methyl groups are present. So 3, 3 dimethyl. Total 4 carbons, and second place, here total 4 carbons means bute. On second place, ketone functional group is present. So we write bute 2-1. Okay, so it is also called as pinacolan. So here we take pinacol, and it can be converted into pinacolan. So it is a rearrangement which takes place by the elimination of water. Okay, here this reaction can be takes place by the elimination of water by using acid catalyzed. So 1, 2 diols can be converted into ketones by using acid catalyzed reaction by the elimination of water. It is called pinacolan rearrangement reaction. Okay, so here the reactant is pinacol and the product formed is pinacolan. In reactant, 2 OH groups are present. 2 OH group means it is a diol, and these are adjacent. So we write 1, 2 diol generally we call, and here the product is maximum carbonyl compound, either aldehyde or ketone, but in most of the cases the product is ketone. Okay, so it is pinacol, and here you get pinacolan. Right. Now how this reaction can be takes place by studying, by taking the mechanism. Okay, so now I write the mechanism for this reaction. You see, this is the first example I will take. Right. If you want to write mechanism for this reaction, you see, so first we take pinacol. So in pinacol, CH3, 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 and 2 OH groups are present. OH, OH. Okay. Right. In first step, in step 1, here H plus. hydrogen ion from mineral acid, it can be reacted with any one of OH group. You see, it is a symmetrical diol. It is a symmetrical diol because you see this carbon contains CH3OH and this carbon also contains CH3OH. Okay, so it takes symmetrical diol. That's why here H plus can be attacked on this OH or this OH, no problem, because it is symmetrical. Okay, so on one place that H plus can be attacked, so it can be changed like this CH3. Now I write here OH2. By the attack of H plus, it can be changed to positive charge. Okay, here OH CH3 it is as it is present. Okay, it is first step, right? In second step, it is first step, right? Now you see second step, it is slow step. You remember this. Here second step is slow step. Slow step means it is rate determining step. Okay, in this rate determining step, this H2O can be eliminated. H2O can be eliminated. After this plus charge can be presented here. Okay, so we get a compound like this CH3, and in this place it is CH3, OH is present. Now here positive charge is present. Okay, this positive charge formation, carbocation formation takes place. So you remember this, in this mechanism, formation of carbocation is slow step and it is rate determining step. Okay, right. After this, you see, after formation of this, here methyl group can be shifted. Okay, so here shifting is takes place, that is 1,2 CH3 shift. Okay, and 1,2 here CH3 group can be shifted. After shifting the CH3 group, you see here this group can be shifted this side, so it can be present like this. Okay, you see here CH3 group can be present, CH3, and already a CH3 group is present. Now one of the CH3 group, it is migrated to this side. Here CH3 group can be present. Now here you see remaining what, here CH3. Now here positive charge is present, and here OH group is present. Okay, right. On next step, you see this bond can be shifted this side, it can be converted to double bond, and this hydrogen, by taking this H plus, it can be eliminated as minus H plus. Okay, by eliminating H plus, here C double bond Y is present. Okay, so finally the product formed is CH3. Now here double bond Y is present and here CH3 is present. Okay, it is pinacolan. It is pinacolan, and here initially we take pinacol. Okay, by taking pinacol, it can be converted into pinacolan. In this pinacolan, rearrangement can be takes place, group migration can be takes place. Okay, and remember your rate determining step is elimination of water and formation of carbocation step, that is rate determining step. Okay, and in this reaction, you see here in this example we take methyl groups we have to take in. Okay, right. Now we take second example. In the second example, in place of methyl group, I take C6H5. That means phenyl groups I can use. Okay, in place of methyl group, here I use phenyl groups. So whenever I can use in 4 places phenyl group, again we get same type of reaction. That means in total reaction, as this reaction is present, but in place of methyl groups, here we use phenyl group. Okay, same reaction it takes place, and all the places we use phenyl group. Okay, and you see here also it is symmetrical because on both sides here same groups are present. On left side and right side pH groups only present. Okay, so that's why here same. But in place of CH3L, phenyl group shifting is takes place. Here pH group, phenyl group is present, phenyl, here phenyl group, and here also phenyl group is present. Now the product is this pH, and here pH, and in this place also pH group is present. Okay, so it is also an example for pinacolan rearrangement. It is second example. In this example, in place of CH3 groups, we use phenyl group. It is also symmetrical. You see on this carbon, pH OH group is present, pH OH group is present. So it is also an example for symmetrical. As the same reaction it takes place, again we get a ketone. Okay, right. It is second example. In first example, you take total 4 methyl groups. In second example, you take total 4 phenyl groups. Okay, right. Now we take a third example. Okay, it is example 3. In example 3, I take one phenyl group and one methyl group. Right. Now you can see it is symmetrical or not. First we want to see. Okay, see this carbon contains phenyl group, CH3OH. One phenyl group, one CH3, one OH group is present. On second carbon, phenyl group, CH3OH. Okay, so it also contains same type of groups. So again, this diol is symmetrical diol. Okay, so again, symmetrical diol means it takes place as it is. Okay, right. After this, up to this it is as it is. Okay, see pH in this place we take CH3, and here also CH3 group is present. pH CH3. Okay, up to this it is as it is. H2O elimination is takes place. Okay, now here a group you want to migrate it. Okay, so whenever you want to migrate a group, whenever phenyl and CH3 two different groups are present, which group can be migrated? Now you have to study it here. Okay, in first example, second example, same type of groups are present, that's why there is no problem. But here when you can see, here one is pH group, another one CH3 group is present. Whenever two different groups are present, which group can be migrated if you want to see. Okay, right now you see here phenyl group and CH3 group, whenever these two groups are present, in these two groups remember pH group can be migrated, phenyl group can be migrated. You remember that whenever phenyl group and alkyl group both are present, in these two phenyl group can be migrated. So after migrating this phenyl group, here it is present compound like this. Okay, so already two phenyl groups are present, this phenyl group migrated this side, three phenyl groups are present, here CH3 group is present. It is third example. Okay, so here you have to remember that order of migrating groups. It is important. Whenever different groups are present, then we can follow order of migrating groups. So in order of migrating groups, you remember hydrogen can be migrated first. After this aryl means benzene ring like phenyl groups like that, those can be migrated. After this, here alkyl groups can be migrated. That means migrating effect is less for alkyl groups. Within the alkyl groups, tertiary having more, next secondary, and least one is primary. Okay, so whenever only alkyl groups are present, in this tertiary is more migrated, after that secondary, after that primary. Okay, but in this example you see here phenyl belongs to aryl, CH3 methyl, it belongs to alkyl. Okay, so here aryl alkyl, these two groups are present. In these two, migrating group is for aryl group, that's why here pH group can be migrated. So you remember that. So in this order compulsory you can remember, whenever two different groups are present, this is the migrating effect: hydrogen, aryl, alkyl. Within the alkyl groups, tertiary is more migrated, after that secondary and primary. Okay, right. Now only aryl groups are present. Okay, in aryl groups, all groups are aryl groups in that condition. Okay, here the groups given all are aryl. Okay, all groups are aryl groups given in that para-anisile, para-toluene, and phenyl, and next para-chlorophenyl. Okay, this is the order. Para-anisile, it is more migrating group, after that para-toluene, and next phenyl, and after that para-chlorophenyl. Okay, and you remember that here on benzene ring, if electron donating group is present, it is easily migrated. Okay, when you compare with electron withdrawing group, within the benzene ring, electron donating group is present, it can be easily migrated. Okay, so it is third example, and you remember whenever different groups are present, like this you have to take it. Okay, right. So you see, in first example we take four groups same, in second example also we take four groups same, in third example we take different migrating groups are present. So whenever different migrating groups are present, in that we have to follow order of migrating groups. Okay, right. Now in these three examples, the compound 1, 2 diol we taken symmetrical. Right. Now in fourth example I take like this. It is fourth example: pH, Me, pH, pH, OH, OH. Okay, right. Now you see, it is also 1, 2 diol, but you see this carbon contains two, one phenyl group, one methyl group, one OH. This carbon contains two phenyl groups, one OH. Okay, that means it is not same. pH, okay, OH, OH, okay, but here methyl group is present, here phenyl group is present. So here that is unsymmetrical diol. So here that 1, 2 diol is unsymmetrical diol. So whenever here unsymmetrical diol is there, there are two possibilities. Okay, so whenever an attack of H+ takes place and elimination of water, by eliminating water, your carbocation, two types of carbocations are formed whenever you take unsymmetrical diodes. Okay, right. For example, from this place H2O eliminated, then it can be formed like this. PH, and here Me group is present. Here H2O can be eliminated, so here carbocation pledge charge is present, and it is as it is. PH, PH, and here OH is present. It is one possibility. Okay, right. Now from this place H2O can be eliminated. In that condition we get another one, that is like this. Okay, you see PH, methyl group, OH, and here PH is present. Now here positive charge. Okay, right. Both are carbocations. In these carbocations, it is pH. pH means C6H5. On carbon pledge charge is present. It is benzyl carbocation. Okay, it is benzyl carbocation. Right. Now on this carbon, two phenyl groups are present. So it is diphenyl carbocation. Okay, here you get two different types of carbocations. It is benzyl carbocation. It is diphenyl carbocation. Okay, when you compare these two, diphenyl carbocation is stable. Okay, so here which is stable? Diphenyl carbocation is stable. That's why here the reaction can be takes place. That means here which group now migrated? Both are pH groups. Okay, here pH Me group, all phenyl group and methyl group is present. In these two groups already we studied, phenyl group can be migrated. After migrating, it can be formed like this, double bond, and here Me, and that is CH3 group is present, and here three phenyl groups are present. So here the migrating group is phenyl group. This group can be migrated. Okay, right. Now you see here the reaction is not takes place because when you compare these two, benzyl carbocation and diphenyl carbocation is stable. Okay, and remember this here, whenever unsymmetrical diol we have to taken, in that condition two possibilities are formed. In the two possibilities, two carbocations are formed. In the two carbocations, which is stable carbocation, from that case only the reaction can be takes place. Here benzyl carbocation, diphenyl carbocation, it is more stable. That's why here the reaction can be takes place. Okay, so it is one example for unsymmetrical diol. Okay, right. Now we take another example. Fifth example. Now we take hydrogens. PHMe hydrogens, it is also unsymmetrical. Okay, so in this place here, in both the cases hydrogen is present. Here also same, hydrogen is present. Now which is possible, now we want to see it. Right, now you see, so again it is PHCH2Me. Okay, it is benzyl carbocation. It is benzyl carbocation. Now here you see the groups present is phenyl group CH3OH. Now this carbon, it is a primary carbocation. Okay, carbon can be attached to two hydrogens, one carbon, means it is primary carbocation. So when you compare primary carbocation and benzyl carbocation is stable. Okay, in this condition benzyl carbocation is stable. That's why here the reaction not takes place. Here the groups can be migrated. On migrating, you see both groups are hydrogens. Okay, that's why one hydrogen group can be migrated. By migrating that, we get like this, MEH. Now here double bond O, and in one place hydrogen is present. Okay, so whenever unsymmetrical 1,2 diols are given in pinnacle rearrangement, here the product formed is based on carbocation which is formed. Okay, so when you study about this carbocation formation, compulsory you have to know which is a stable carbocation. In that case only migration reaction can be takes place. Okay, right. It is also one example. Right. It is about pinnacle and diols reaction. And here one more example we studied, which is not a diol, but it is also follows pinnacle and rearrangement, that we have to see here. It is sixth example. It is not a diol. We take like this: CH3, 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 CH3. Now in one place I take OH. In another place, in place of OH, I take NH2. Okay, it is also follows this reaction, but it is not a diol. So whenever OH, NH2 are present, here the mineral acid used is HNO2. Okay, so whenever in this reaction HNO2 is used, here NH2, it having amine nature. Amine on reaction with HNO2, diazotization can be takes place. On diazotization reaction, that NH2 can be converted into N2, diazonium. It can be formed as diazonium. Okay, so it can be present like this: N triple bond N, and nitrogen contains positive charge. Okay, it takes place by the elimination of water. Okay, by the elimination of water, here diazonium formation takes place. After formation of this, here N2 nitrogen gas can be eliminated. Now here positive charge is present. Okay, after presenting positive charge, CH3, and here CH3 OH, CH3 CH3, and in this condition here positive charge is present. Okay, so here you see both are CH3 groups are present. One CH3 group can be migrated. Okay, after migrating that 1,2 shift, here also 1,2 shift takes place. After shifting, here it can be present like this. It is double bond O and one CH3 group present, and in remaining condition here total 3 CH3 groups are present. Like this reaction takes place, you are no need to take a stable carbocation formed or not formed, because you are not considered it is stable carbocation or not, because here it is a diazotization reaction takes place. Diazonium is formed. Okay, compulsory where diazonium is formed, in that place only pledge charge is present. From that here migration can be takes place. Okay, it is overall about pinacol rearrangement. In this reaction 1,2 diols are involved. The product formed is carbonyl compounds. In maximum cases the product is ketone. Okay, it is acid catalyzed rearrangement. That means this reaction takes place in presence of acid catalyst. Okay, in most of the cases in this reaction we use H2SO4, and if the diol is symmetrical diol, in that condition only one product you have to get, that is the major product. Okay, and migration, whenever two different groups are present, in that condition compulsory follow migrating group order. Okay, whenever it is unsymmetrical, in that condition compulsory we can see formation of carbocation, which is more stable carbocation. From that the reaction can be takes place. Okay, it is overall pinacol rearrangement reaction.